So here's a question I have. We just rolled a bunch of dice, yes? We just rolled a bunch of dice. What's the chance of getting a 3?
1 in 6.
I hear 1 in 6. Is that fair? When Andrew says 1 in 6, how is he answering? Is he answering theoretically or is he answering empirically?
Theoretically.
He's answering theoretically, is he not? Because what did he just do? He got a sample space and an event space. You actually answered this one on your last project, I think. Roll a die. What's the sample space? How big is the sample space? 6. 1, 2, 3, 4, 5, or 6. Boom. That's how many things can happen, yes? What is the event space you're interested in? I'm asking you what's the chance you got a 3?
3.
Okay, well, getting a 3, good. I love that, Jordan. So how many ways can you do it?
1.
That's why it's 1 in 6. What I want to do right now is I want to keep track of what we got. So we may have to do some collation here. So we're going to let x equal the pips that we saw on a roll. Okay, and then I'm going to keep track of a frequency chart here. So there are 6 possible things that could happen, yes? Got this pointed the right way? Yes. 1, 2, 3, 4, 5, 6. Let's just collate data now. How many of you saw, we're recording, good. How many times did we see 1? How many times did we see 1? Let's hold hands and fingers to show me how many times you got it. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 12. That's 28 ones. Thank you, Tori. And Shelly, did you have any ones?
Yes, I just counted them and then I forgot.
That's okay. I'm sorry. You can count me. We'll add to that.
16 ones.
28 plus 16 is 44, yes? 44 ones altogether that we saw, yes? All right. How many 2s did we see? Let's do 2s. How many 2s did we see? 9, 10, 11. Wow. 19, 22, 26, 28, 29, 30, I think. 30, and then we got 30 plus 17 is 47. Then we got Tori's.
19.
Plus 19. 47 plus 19 is 66. You can do that right. Good. 3s. How many 3s did we get? No 1s or 2s or 3s yet. Good. Very nice. Brittany rolled a die over here and got no 1s or 2s or 3s. Oh, you had two 1s? I count you in that. I count you in that. I didn't see you over there. Thank you. 46. Sorry, I didn't see Brittany sitting over here. Oh, I saw her sitting over here since your hand up. So 46, 60, 3s. Here we go. 3, 6, 7, 10, 12, 13. That's 6, 19, 20, 3, 4,
18.
46,
15.
61. You know? Love it.
Junior high is holding up a 5, right?
Oh, I did not. So I have 2 more. 63. Thank you, Ryan. 4s. 10. Goodness, this is awesome. Die. Crap, I lost count. Hold this up again. I lost count. ADD is sometimes a problem. 7, 10, 17, 18, 23.
12.
So that's 35,
11.
46.
Plus 2.
Oh, plus 2. 48. Thank you, Ryan. I jumped right over that time. My apologies. My apologies.
Well, I didn't have my hand up at
All
the
good.
time,
All
so.
good. I'm like an infant. I see motion. Redeem. 5s. Nick, you got 5? That's 22, 23, 27,
9.
36,
7.
43, I think. I did that right in my head. Good. And 6s, this is perfect. Well, just in time. I'll do double dice next time. 1, 2, 3, 4, 5, 6, 7. This is awesome. 7, you go a bunch of times. 7 plus 9 is 16, 17, 18, 19, 24, 27,
12.
39,
14.
63, I think. 65. All right, friends.
I got a soul.
That's one.
47. There we go. Anybody else holding out? Speak now or forever lose your data. We good? All right, you ready?
That's weird.
Good. Hold that thought. Let's do the probabilities empirically based on this data.
What's the sum?
I don't know. That's what to figure out, right? We have to figure out how many trials we saw. That's a great question, Benji.
I got it.
Let's figure the probabilities out. So the first thing we have to do is we have to sum this. Sum the frequency. I'm going to use a Greek letter here. Get ready for 243, those of you going on that journey. That's a big sigma. Big sigma always means to add. So you'll see that. Say it again.
332.
We saw 332 trials. Fan-freaking-tastic. 332 trials. Our job now is to get these decimals down. Get this up, because the problem is, Benji said this is weird, and I agree with him. We've got some neat clumping going on, which we would kind of expect to see, honestly. Now, there was also some weird data collection going on today. I love the spilling of the tin. That was fantastic. It's never happened before. Hope it happens more frequently. I'm tempted to actually just walk into class one day and just throw a bunch of dice on the floor. Go, count them! And see what happens. but nonetheless, let's just go with this data right now. So the chance of 1 empirically is going to be 47 over 332.
0.14. How many? So how much?
Round it to 2 decimals.
All right. Yeah. 1.14.
0.14. Let's keep going. 66 out of 332.
198.
We'll call it 0.2.
Okay.
Yeah. 63 out of 332, it should be similar. It should be 0.19, is that round up to 19%?
Yeah.
48 should be, I guess, 14% again, I'm guessing.
Yes.
43 is going to be probably, I'm guessing,
39.
13.
13%. Yeah. And last but not least, 65 is probably going to match this.
195.
195, we'll call that 0.2, yes? Theoretically, what should they all be? They should all be the same, and there should all be what? 1/6 repeating. 1/6. So this 1/6, you can totally write as a fraction, and I love it, but it's approximately equal to technically 17%. It rounds to 17%, just for different number 6. 1/6 repeating, exactly. But if you have to stop it at some point and talk about it. So you can see how we're off. But we're off. Say that again, Andrew.
It's not intensely off.
It's not intensely off, and we only ran 332 trials, yes? So what we're going to do now is we're going to take a look at our previous Excel extravaganza and look at a new one and see how it compares to our results. It's okay, it's still running. I didn't forget about it, I just ignored it for a while.